Okay, so good morning, good afternoon, good evening, everybody from wherever you are joining us. Welcome to today's session on AI ethics. Right. So we have our speaker today, and I'm really excited that we have been having these sessions right from the one to the very last day, and starting from the first day introduction to AI, and we are now in looking at building responsible AI systems. So, I mean, thank you everybody for joining. I can see Abraham Obianke. I feel like we should give you a gift. I mean, we are really being consistent. So today we are going to look at responsible AI ethics, how to you how taking considerations when taking this ethical consideration when using and building responsible and using AI, that is responsible AI. So um, if we look at the entire life cycle of designing machine learning system, we have responsible AI included. So without much talk, I'll have at this point. So I'm going to call our speaker, a very beloved speaker, Sarah. She's really cool. She's an expert in research and machine learning to take over and then continue the session.
All right, thank you.
Yeah, I can leave the stage, right?
Yes, sorry.
I can leave the stage, right?
Yes, yes, you can. Yes, you can.
Okay.
All right, hello everyone. This is Sara El-Ateif back with you. I hope you have had a beautiful week. So, what we're going to talk about today is AI ethics. So, you know, when we develop the models, we train them, we deploy them. Usually, one of the things we know of, and some of us do, is we implement what we call explainable AI tools to be able to explain what our models do and why they do what they do. So, what is exactly explainable AI, right? So, explainable AI is a set of processes and methods that allow human users, the one that are using our models, to understand and trust these models' results. That's it. That's really the big thing that explainable AI is. So this is actually like, at most, this is what we do after we have deployed our models and made them available for everyone to use. But the problem is that, I mean, let's dive deeper into what explainable AI is. So today, what we actually have most of the time, even till now, is that we have our training data, we feed them to the machine learning model, we have the model learning what it needs to learn from the data, then we provide a decision or recommendation, right? Then the user, when he receives the prediction, especially people who are smart, they start questioning why the model did that. How did the model come up with that conclusion or result, right? So, for example, why did the model do what it did? Why not? Why didn't it do something else? When did it succeed? When does it fail? How can the human trust the model, and how can we humans correct the error of the models? With xi, which is explainable AI, what it provides us is it provides human beings with the possibility to understand why the model made the prediction it has done, why it didn't make another prediction, when it succeeds, when it fails, when to trust it, and how to fix the errors it is providing. So, this is what we hope explainable AI would provide us with. It is not exactly what we have till now. We still have, like, most of the algorithms that are in explainable AI, they either show you, like, kind of like explain what the model did, where it looked at, for example, to make its decision, but we have no way to fix the errors usually. That is why it is very hard to trust these models. And if you know of these, so there have been like just a few decades, or not decades, but just a few years ago, we developed models called deepfakes. So what deepfakes did was that you provided them perhaps a picture of someone and they might change their face, or you give them the picture of someone and you want them to adapt it to, I don't know, celebrity's face sometimes. This created a huge deluge, right, of misinformation. So we have a lot of data out there generated right now, thanks to generative AI, that might not be true because it hasn't been fact checked and it has been generated by AI. This is the biggest dilemma that generative AI has caused us. There are also some issues with privacy breaches that generative AI has created as well, like mishandling the data that it is provided with. There are also issues of copywriting. I'm not sure if you heard of this, but several big names in image generation, like for example, what do we call them? Yeah, Midjourney and who else? Mm, I'm trying to remember whose names. So, for example, Leonardo the AI, even OpenAI actually has been sued a couple of times because they trained their models on artists' work, other designers' work, without their approval. So, this is another dilemma that generative AI has caused. There's also issues of transparency that is related mostly, obviously, to explainable AI. For example, AI systems function as opaque entities, so we do not know how they make their decisions. Which means the models that we have available do not tell us how they made the decisions they made, why and when, for example. There are also the data origin concerns. So, for example, the data these generative AI models might be trained on, it might actually like focus only on one area of the world. Let's say, for example, all of generative AI models have been trained on US data, but people outside of the US, for example, Africans, they use it as well. And so, whenever it is providing us with answers, it is providing it based on standards in the US and not in Africa. It does not respect our cultures. It does not provide us personalized answers. So these are issues that we have due to the data concerns. There are also instances of AI generated misinformation, like, for example, the deepfakes. There are also news that have been generated with AI. There are also actually sometimes like students use AI to help them do their homework, but then obviously they do not double check the answer and end up giving the wrong the wrong reasoning. This is where AI ethics come. They come to help us set some rules, some guidelines, so we can develop models that are trustworthy, secure, fair, reliable. Things we can use while feeling like we are in control and we can at any time not, for example, choose to use it, right? Or even if we use it, we know when it fails, where it fails, and why it fails, and what type of values it is following. So, what are AI ethics? So, AI ethics are a set of guiding principles that stakeholders are the ones that are making decisions. That might be engineers, or for example, as machine learning developers, data scientists, to government officials, like people taking decisions and kind of like issuing rules, laws, and all of that. So these guiding principles are used to ensure that artificial intelligence technology is developed and used responsibly. This means taking a safe, secure, human, and environmental friendly approach to AI. So this is based on a Coursera article around AI ethics. But let's dive deeper. So, what does it exactly mean? So, when we're talking about ethical AI, We're talking about things that are related to the algorithm. That is, the algorithm has to be transparent, explainable. That means we understand it did a certain prediction, we know why, when, and how to fix it. It needs to be fair. What does that mean? I don't know. For example, there have been a lot of complaints are for like in UK, some of them have developed models for recruitment. But these models, what they did was that, for example, whenever they saw someone like with a black skin tone, or perhaps, for example, wearing a hijab or something like that, a veil, they will discard them from the discard them from the candidates pool. So this is an issue. This is not fair, right? It is not judging the individual based on their skills. It is actually judging the individual based on their ethnicity, for example, or their religion, or something like that. There is justice, and this is obviously also related to fairness sometimes. So justice means it has to provide us with a judgment. That is, for example, it cannot kind of like, how do we say it? Mm, it cannot prefer one person over another. I don't know, like we humans do sometimes, because they have the resources. They have, for example, money. So we kind of like might discard the fact that they did something wrong simply because they have money or something like that, or status, right? There is also inclusion. So it needs to take into consideration everyone's cultures, right? Um, Religion, perhaps, beliefs, or anything actually that is different in us. So it needs to include as many people as possible. Privacy. People should not and cannot use our data without our consent. This is one of them, data privacy. Privacy might also come from securing these models. That is, even if someone actually hacks, I don't know, hacks the system where the AI is, no one can use the AI model to kind of like generate the data it has been trained on, especially in sensitive areas or domains like healthcare, because like some people do want their health data to stay private, right? For example, some people, if they have some kind of issue, a psychological issue, they do not want, for example, their friends or family to know about it. So they want it to stay private. So this is obviously preferences, human preferences. It is our right to keep what to keep ourselves as safe. Responsibility. Who will take the the biggest example that is like usually kind of like who is yeah so that is actually kind of like portrayed in this setting for responsibility. I'm sure you might know about this. So it's the one with the car, self-driving cars. So let's say, for example, we have an AI deployed in a car, right? It is driving the car itself. Let's say someone, I don't know, there is going to be, for example, there is someone crossing, the car is about to hit, I don't know, the motorcycle perhaps that has a youngster, and then there is an old man walking down the road. Who should it hit, right? And there's like no way to evade both of them. We can only evade one. Who should it be? It's very tricky question to answer. Like even for human beings, it is extremely tricky to answer this kind of question, right? So when something bad happens, who will take when someone bad happens, who will take the actual responsibility? Who is going to be accountable? That is what. Also, accountable means that they will have to answer to the problem and kind of like solve it. Responsibility means that you will have perhaps to compensate or something like that, right? So for AI ethics, which is not ethical AI, right? Because ethical AI, it is the algorithm that need to have a set of principles. AI ethics is things that you will hear a lot of researchers and even like people, uh, activists and all of that talk about it. That is, kind of, it has everything to do with our social aspects. That is kind of like, how should AI algorithms be? The transparency, explainability, fairness, obviously they were defined by humans. And then there are legal aspects. Who should be, for example, if the model fails, who should be held accountable if the model makes a mistake? There are also like innovation, inclusion, diversity. Anyway, it's a lot of headache things. The only thing you need to remember is that it is, how should we design the AI models? How should the AI be? Who should take responsibility if something happens? And kind of like the principles that we follow. And usually they are obviously defined by society and a couple of other influential people. So before we go on with resources, I just want to show you a couple of examples. Let me find my slides. The other slides. Fairness, so ethical ML. I'm going this time to show you my slides from, not my slides, obviously. These slides are from Google AI, and they do talk about ethical machine learning, fairness, and they give some really great examples. So I want to share them with you. Victor, can you please share the other slides when they're ready? Thank you. Let's wait for them to process. Meanwhile, while they're processing, let me share with you some of the resources where you can learn more about this ethical AI thing. There's this great video. There's this great video from UNESCO that talks about the challenges and governance. There's another amazing video by IBM that talks about AI ethics in practice. There is this amazing set of principles shared by UNESCO, like the values we should be striving for. They have a couple of other examples as well around the things that we should be doing and should not be doing. So let me go to the example where we have. All right. So yeah, the biggest issue around AI is that it actually mirrors our biases. Well, obviously, AI models, especially generative AI models, I mean, all AI models are trained on data that we human beings generate, right? But it's specifically generative AI models because they are kind of like conversation. They have this conversational tendency. So they actually like very, very highly replicate almost all of our biases. What are biases, by the way? So biases are things that we default to, things perhaps that we like, or things that comes from our own experience. So they are things that are related to us as ourselves. So for example, my own preferences, Sara El-Ateif's own preferences, Sarah's own, I don't know, limiting beliefs, like, Sarah's own beliefs, right? So these are things that are my own. So our biases are our own, right? So they are, obviously, we do share them in society. Some of us, for example, do have some biases that we share. And these biases, they are kind of like echoed in these AI models. So you can find them and they are amplified. And this is why it is causing a problem. Because obviously we human beings already suffer from these biases. But now we have other tools spreading these biases to other people. So let's identify some biases in these AI models. So we will see three: missing feature values, unexpected feature values, and data skew. So for the missing feature value example, so look at this data. You can see here that latitude is 17,000, total zoom is 17,000, population is 3,000, household 3,000, median income is 3,000. Doesn't it look a little bit fishy to you? And the thing is, all of these features have a count of 1,700. indicating that there are no missing values. But let's look deeply into this. So these three features, population, households, and median income, only had a count of 3,000. In other words, that there were 14,000 missing values for each feature. So these ones have 17,000. This total rooms has 17,000 in its count. Median house value has 17,000, but population has only 3,000. So where is the rest, right? Where is 17,000 minus 3,000 has gone to? And they say there is, look at it. They say this is a sample data set from California housing data set. They say that there are no missing values. Then where are the 14,000 for population, households, and median income? What are they called, right? This is one. Let's look at this example here. So here we have these informations provided, and they ask us, can we pinpoint any unexpected feature values? So because we're not in the US, it's very hard to actually spot this. But the longitude and latitude coordinates in the fourth example, which is minus 103.5 and 43.8 respectively, do not fall within the US state of California. If you remember, this is a data set around California housing. So normally, the data set should be, the latitude and longitude values should actually have, obviously values that are in California. So these values of minus 103.5 and 43.8 respectively are approximate coordinates of Mount Rushmore National Memorial, which is in the state of South Dakota, which is obviously, this is just like one of the errors that are committed and echoed in the data sets. So let's see the data skew example. So California state map overlaid with data from the California housing data set. Each dot represents a housing block with colors ranging from blue to red, right? Corresponding to median house price, ranging from low to high respectively. So we have the median house price. So let's evaluate for bias. So consider a new model developed to predict the presence of tumors. That is evaluated against a validation set of 1,000 patients' medical records. 500 records are from female patients, and 500 records are from male patients. So we have half-half, right? Which is very much tricky. I mean, it's not logical, right? It's very rare for us to have in a data set an equality when it comes to gender in whatever it is form. Not that I am saying that equality is not a thing, but it is definitely not a thing, even in medical, right? I mean, it is tricky. So the following confusion matrix summarizes the results for all of these 1,000 examples. Let's look at them, right? So we have true positive 16, false positive 4, false negative 6, true negative 974. So if we do the count, this is obviously 978, 78, and then the 616. And then when we do the precision and recall, we have 80% for precision, 72.7% for recall. Well, let's look at the female patient results. So of the 11 female patients, interesting, who actually have tumors, the model correctly predicts positive for 10 patients, recall rate of 90.9%. In other words, the model misses a tumor diagnosis in 9.1% of female cases. All right. Similarly, when the model returns positive for tumor in female patients, it is correct in 10 out of 11 cases. Precision rate is 90.9%. In other words, the model incorrectly predicts tumor in 9.1% of female cases. So how probable is that? Usually precision and recall are usually always different, right? They're not exactly the same, no matter how you look at it. So let's look at it this way. So if we look, excuse me, let me just move on to the next slide. Now let's look at the male patients, right? So we have precision of 60.6%, 66.7%, sorry, and we have 54.5% for recall. Awesome. So of the 11 male patients who actually have tumors, the model correctly predicts positive for only 6 patients, which is a recall rate of 54.5%. That means the model misses a tumor diagnosis in 45.5% of male cases. Doesn't it seem like this model favors women over men? Because its precision and recall were really high for women, but then very low for men, right? So this is a bias. So when the model returns positive for tumor in male patients, it is correct in only 6 out of 9 cases, which is precision rate of 66.7%. In other words, the model incorrectly predicts tumor in 33.3% of male cases. To be honest, I think this model might be much more, for the male one, might be much more realistic than the one for the female one. So we now have a much better understanding of the biases inherent in the model's predictions, as well as the risks of each subgroup if the model were to be released for medical use in the general population. So technically speaking, this model will work perfectly for women, but then it will fail grandiosely for men, which is obviously a disaster. Can you bring back the other slides, please? Victor, can you please bring back the other slides? Bring back yeah. Thank you. So I do highly recommend you check out these resources and go through the UNESCO ones. But also, there is an amazing, awesome course in Kaggle called Intro to AI Ethics. They do not only explain what the concept is, but they also teach you how to design models that are fair and follows AI ethics step by step with lots of amazing exercises. Do you have any questions for me? Do you have any questions or should we wrap up?
Okay, I don't have any question. I mean, you have talked about, but can you go back to the previous slide, the first slide about the resources?
This one, challenges in governance?
No, go forward.
Which one? Which one?
The one before, just go forward. Yeah, this one. You have passed.
Mhm.
Just one part.
Yeah.
The other one, the one before this one.
Okay, this one, values to strive for.
Yes.
Yes. What is the question?
The question is, I don't really have any question to be honest, but I just love the slide. You know,
Yeah,
the
about the values, right? Yeah. Well, these are some aspiring values, but I'm not sure, we kind of like can really exactly respect them with AI today. It's very hard. Like,
yes,
to be honest, AI ethics to me is like It's like diversity and inclusion. It's just out there for the funding, but not exactly implied
Yeah.
anywhere.
So why is your cargo green, not blue? Because mine is always blue. Why is it not blue?
What?
Your cargo your cargo color is green, not blue.
My cargo color is
I knew.
green.
Yeah,
This one?
yeah. Sorry, it's blue now. I actually thought it was green, but
No,
it's
no, no.
okay.
It is blue. It is blue.
Oh, no problem. Thank you. So send.
You're
I need
welcome.
the link to put the two slides, and so I can share it on YouTube.
Yeah. All right. Let me just put them in Drive and then send you the link. Okay.
Okay. So far, we don't have any other questions. So how do I get the recording from here? I can end recording, right?
Sorry?
I can end recording, right?
Yes, yes, you can. Yes, you
I
can.
can end recording.
Yeah, yeah, yeah. Go ahead.
Okay.
Here we go.
Thank you.
You're welcome. Here, here are the slides.